Good afternoon, everyone, and welcome everyone here in person in Washington, D.C., and those of you following the event online to the 2021 Lawrence Award ceremony. I am Dr. Asmeret Assefaw Berhe. I'm the Director of the Office of Science here at DOE and will serve as your host for today's ceremony. It is my pleasure as we start the event to first introduce Secretary Granholm, who has provided pre-recorded remarks for the event. Please watch with me on the large screens here in the room. You have one here up front and one in the middle, and listen to Senator Granholm's remarks.
Hello, everyone. I sure wish I could be there with you in person today. But I am grateful to Dr. Berhe and the Office of Science for putting on this event and for supporting really generations of scientific talent. You know, one of my favorite parts of being the Secretary of Energy has been getting to interact with the scientists and the researchers and the engineers across this agency who just happen to be among the best in the world. These folks are why I call DOE America's Solutions Department. If you are one of them, they are strengthening America's leadership and competitiveness in fields ranging from computing to physics, working to cure diseases we might not even know about yet. And they're building a smart, clean energy economy that works for everybody. Fundamental, groundbreaking science is the core of the DNA of this department and to our success as a nation. But as the namesake of today's award, Ernest Lawrence, once observed, he said, "Scientific progress requires a favorable environment." And President Biden knows that. He has made it a priority for this administration to create that favorable environment. It's why in his very first week, President Biden directed every federal agency to make evidence-based decisions guided by the best available science. It's why DOE has increased our budget for the Office of Science. It's why we are investing in strengthening the pipeline into STEM careers for young people of color. And it's why President Biden's legislative accomplishments, the Bipartisan Infrastructure Law, the CHIPS and Science Act, the Inflation Reduction Act, it's why they invest around $55 billion in the Office of Science and in our national labs. And in doing so, we're very proud to carry on Ernest Lawrence's legacy. Lawrence, as you probably know, was known as the father of big science. And that's because in the 1940s, he saw that when government invests in science, and I mean really invests in big tools, that's when we get our most miraculous breakthroughs. The Lawrence Award honors that notion by awarding $20,000 each to mid-career scientists and engineers who've made outstanding scientific and technical and engineering achievements under the DOE missions. It's one of the oldest and most prestigious scientific awards from the U.S. government. Previous winners have gone on to become national lab directors, DOE leaders, teachers, Nobel Prize laureates. And today, we're adding 10 more to the group, each one of them making amazing contributions to our collective safety and health and sustainability. So, our Lawrence Award laureates are Dr. Matthew Beard in Atomic, Molecular, and Chemical Sciences, Dr. Jennifer Pettridge in Biological and Environmental Sciences, Dr. Andrew Landahl in Computer, Information, and Knowledge Sciences, Dr. Rachel Siegelman in Condensed Matter and Materials Sciences, Dr. Ji Zhao in Energy Science and Innovation, Dr. Louis Chacon in Fusion and Plasma Sciences, Drs. Philip Schuster and Natalia Toro in High Energy Physics, Dr. Daniel Synars in National Security and Nonproliferation, and Dr. Sofia Quaglione in Nuclear Physics. In his speech accepting the Nobel Prize in Physics, Dr. Lawrence urged us to, quote, "cherish the hope that the day is not far distant when we will be in the midst of our next adventure." I look forward to hearing about the adventures that our awardees lead our nation on. Congratulations to all of you, and thank you for your service.
Next, it's my pleasure to introduce Mr. Frank Rose, Principal Deputy Administrator of the National Nuclear Security Administration.
Put this up here. Good afternoon, everyone. It is a pleasure to be here today as we honor the 2021 Lawrence Award laureates. Welcome to our incredible honorees and to everyone for joining us today in person or virtually. As Principal Deputy Administrator of the National Nuclear Security Administration, or NNSA, one of the highlights of my role is getting the opportunity to meet and acknowledge the top-tier scientists and engineers whose tireless efforts advance the Department of Energy's national security, science, and energy missions. Established in 1959, the Lawrence Award is named for Dr. Ernest Lawrence, the inventor of the cyclotron, the recipient of the 1939 Nobel Prize in Physics, and the only person with two national labs named after him, Lawrence Berkeley and Lawrence Livermore. The Lawrence Award, administered by the Office of Science, honors mid-career scientists and engineers whose exceptional contributions and achievements have helped advance the national, economic, and energy security of the United States. Dr. Lawrence's ideals of collaborative discovery and innovation helped establish the era of what the Secretary said, big science, using multidisciplinary teams of scientists and engineers with sophisticated equipment to conduct experiments on a massive scale. His spirit carries on in the laureates we honor and celebrate today. And now on to the award recipients. This year's awardees represent true excellence in their respective fields and embody Dr. Lawrence's dedication and passion for scientific discovery and innovation. The Lawrence Awards span 9 categories covering a wide array of scientific and engineering fields. It is my pleasure to introduce you to 4 of this year's 10 awardees who have advanced the Department of Energy's missions in national security, science, and stockpile stewardship. Dr. Daniel Senars of Sandia National Laboratory for his accomplishments in national security and nonproliferation. Dr. Senars' accomplishments include pioneering the development of diagnostic techniques and experimental platforms in the fields of high energy density physics and inertial confinement fusion. Dr. Senars' scientific contributions have been pivotal in transforming Sandia's flagship Z machine into a high precision instrument for stockpile stewardship and in laying the foundation for several record-breaking experimental platforms on the Z machine. Dr. Sophia Koulagani of Lawrence Livermore National Laboratory for her accomplishments in nuclear physics. Her accomplishments include advancing nuclear structure and reaction theory, the development of ab initio, did I get that right, Doctor? Or first principle calculations of nuclear reactions and seminal work towards future implementation of those calculations on quantum computers. Her work on ab initio treatments of nuclear dynamics has paved the way for more complete picture of the nuclear process and demonstrates the overlap between the Office of Science and NNSA, where cross-cutting nuclear and quantum science is applied to both national security issues and the fundamental study of atomic nuclei. Dr. Andrew Landahl of Sandia National Laboratories and the University of New Mexico for his accomplishments in computer, information, and knowledge sciences. Dr. Landahl's accomplishments include the invention of the minimum weight matching decoding algorithm for surface codes and the development of future quantum programming language in quantum algorithms for stockpile stewardship. Now that was a tongue tie there, but I got it. As part of the National Quantum Initiative Center at Sandia, Dr. Landahl's work sits at the forefront of research in quantum error correction and addresses critical problems relevant to quantum computing and QIS, an area that is central to department missions. And finally, Dr. Louis Chacon of Los Alamos National Laboratory for his accomplishments in fusion and plasma sciences. Dr. Chacon's accomplishments include developing state-of-the-art codes, which have made seminal contributions in computational mathematics and simulations in plasma and fusion sciences. Dr. Chacon's work has recently been applied to the inertial confinement fusion and is critical to design and strategic decisions governing multi-billion-dollar investments in flagship fusion facilities. Through their leadership and cutting-edge contributions, each of these honorees has helped us to better understand and study the fundamental physics of our universe, come closer to unlocking the potential of fusion, and improve the safety of our nuclear stockpile. To conclude, I would like to underscore how important our scientific and engineering personnel are to our department and the nation. Your work places you in a long legacy of accomplished Lawrence Award winners, some of whom have joined us today. Once again, congratulations on your accomplishments. Thank you so much.
Next, it's my pleasure to introduce Mr. David Howell, the Acting Director of Office of Manufacturing and Energy Supply Chains and the Acting Director of the Vehicle Technologies Office in the Office of Energy Efficiency and Renewable Energy.
Thank you, Dr. Berhe. It's a pleasure today to represent our applied research offices and particularly two particular recipients of this year's E.O. Lawrence Award. Again, I'm Dave Howell. I'm the Principal Deputy Director of the Manufacturing and Energy Supply Chain Office, a new office here at the Department of Energy, and continue to be the Director of the Vehicle Technologies Office. So EERE relies on the nation's top scientific talent to tackle some of the most pressing challenges of energy today. It's so important to have this top talent able to translate fundamental science knowledge into actually real world end use applications. And that's what we underscore in EERE and the Manufacturing and Energy Supply Chains Office as well. So today it's my honor to introduce you to two of the 2021 Lawrence Award laureates, whose scientific achievements, including advancing the pursuit of next generation energy conversion and storage systems, are central to the department's mission. So first, Dr. Jie Zhao of Pacific Northwest National Laboratory and University of Washington is honored for achievements in energy science and innovation. This award category specifically calls for accomplishments in use-inspired sciences. Dr. Zhao is recognized for her research achievements in electrochemical materials and battery technologies, including development of a suite of methodologies to correlate fundamental properties measured across multiple scales that have become widely integrated in DOE and international battery research programs and the discovery, design, and practical application of novel energy storage materials. This includes her invention of advanced electrode materials based on functional graphene sheets to achieve high energy densities for lithium air batteries or lithium oxygen batteries, and the development of high voltage cathode materials for lithium ion batteries. And for a demonstration of the complex reaction and the failure mechanisms in industry relevant high energy lithium metal cells, which challenged long-standing hypotheses and proposed new solid electrolyte interface structures. As Deputy Director of the Battery 500 Research Consortium, her work has helped enable a more than 10x improvement in the cycle life of prototype high energy lithium batteries, promising to move more than double today the energy density of today's lithium ion systems, representing the best performance reported to date for rechargeable lithium metal batteries. And secondly, I'd like to honor Dr. Matthew Beard of the National Renewable Energy Laboratory for his achievements in atomic, molecular, and chemical sciences. He is recognized for pioneering work in the study and control of hybrid organic, inorganic perovskite semiconductors, multiple exciton generation, terahertz spectroscopy, and their energy applications. His work has identified promising mechanisms to enhance solar energy conversion and the development of efficient next generation solar cells. The groundbreaking nature of his research is evidenced by the number of firsts that have emerged from his research. This includes the first demonstration that multiple exciton generation occurs in isolated quantum dots using ultra-fast laser spectroscopy. His work led to the creation of quantum dot solar cells with record power conversion efficiency and has inspired the creation of a new program areas in perovskite photovoltaics. Dr. Giles and Dr. Beard's deep understanding of both fundamental energy processes and practical issues associated with the energy technology are key to advancing DOE science and energy missions. Dr. Giles and Dr. Beard's work represent shining examples of how fundamental research funded by the department forms the foundation of energy technologies and highlights the importance of building interdisciplinary teams, as they both have done through Dr. Giles' role as the Deputy Director of EERE's Battery 500 Consortium and Dr. Beard's role as Director of one of the Office of Science's Energy Frontier Research Centers. So on behalf of the Department of Energy, I would like to congratulate you for your accomplishments and selection for the Ernest Orlando Lawrence Award. Thank you.
Thank you, Frank and David. Now it's my turn as the Director of the Office of Science. And I just want to start by saying I'm really thrilled again to be here with you all celebrating the recipients of the 2021 E.O. Lawrence Award winners. So the E.O. Lawrence Award was established in 1959 by President Eisenhower in honor of a scientist of extraordinary importance, not just in the nation's global standing in physics, but also to the Atomic Energy Commission, the predecessor to today's Department of Energy. Dr. Lawrence's unique contributions to science, including, of course, the invention of the cyclotron, laid the foundation for the big science that department is now known for in this era. Not to mention, of course, earning him the Nobel Prize. No pressure, of course, on anybody here. These awards first bestowed in 1960, were intended to honor extraordinary scientific and technical achievement and to inspire others to dedicate themselves to scientific discovery in the service of the nation. Today's event and the awards we're bestowing to this incredible group of researchers then is an opportunity for the department to honor the accomplishments of the winners and to inspire future generations of scientists and engineers to join us in the pursuit of our mission, which has never been more important. But this award also honors not just the exceptional technical achievements of our laureates, but also their extraordinary records in mentorship and service to their communities. Before we present the awards and hear from the laureates, let me say a few words about the Lawrence Award program itself and how we arrived at today's cohort of winners. The Office of Science manages the Lawrence Award program on behalf of the Secretary of the Department of Energy. The nominations are first solicited from the community within each of the technical categories representing the breadth of the DOE research mission. The nominations are externally reviewed by established scientific leaders and technical experts relevant to each category, representing an array of institutions that include academia, DOE national labs, US federal agencies, international labs, and industry, and include previous winners of the Lawrence Award, previous laureates themselves. The laureates we honor today then were selected based upon results of this very rigorous external expert review and received the full endorsement of the Secretary of Energy on May 13th, earlier this year in 2022. It's one of the highest priorities of this administration and for my own directorship of the Office of Science to ensure that our community in the science and technology sector is inclusive and open to all of the talent that America has to offer. We, of course, recognize that we have much more work to do to realize a community of scientists and engineers that truly looks like America. And I'm proud to say that the Lawrence Award winners for 2022 reflect that priority. This year's awardees represent true excellence in their field and now join the community of past laureates representing the best of what DOE science and engineering has to offer. And let me introduce the 4 laureates from the Office of Science. It's my honor, of course, to introduce 4 of the 10 2021 Lawrence Award laureates. The first one, Dr. Jennifer Pettridge of Lawrence Livermore National Laboratory and University of California, Merced, is honored for accomplishments in biological and environmental research. Jennifer Pettridge is recognized for her innovative leadership and substantial contributions to foundational research, technological development, and application of experimental and isotopic tools in the field of quantitative microbial ecology. Specifically, she pioneered the development and application of stable isotope tracing techniques. For example, stable isotope probing or SIP, NanoSIMS, ChIP-SIP, QSIP, all techniques that enable new quantitative approaches to illuminate how environmental biogeochemical processes and ecosystem functioning are influenced by microbial metabolism, diversity, and function. Applying these new approaches in soil systems, Dr. Pettridge's work has fundamentally transformed our capacity to evaluate carbon sequestration strategies and predict climate change impacts. Her accomplishments help advance DOE's science mission to understand and model the Earth system. The second laureate that I'm going to mention is Dr. Rachel Segelman of University of California, Santa Barbara, who's honored for her accomplishments in condensed matter and material sciences. Rachel Segelman is recognized for leadership in innovation in polymer physics and chemical engineering that have led to new polymer design principles in energy applications. Accomplishments represent advancements in several areas of polymer science, including semiconducting polymer self-assembly, thermoelectrics, polyionic liquids, and peptoid materials. Dr. Segelman's work bridges a desire to fundamentally understand ion transport within model systems with applied sciences in the design of full solar cell systems, membranes for water purification technologies, and mixed lithium and electron conducting materials for battery binders. She is considered an undisputed thought leader who is motivating many young leaders to apply self-assembly methods to fundamentally advance organic electronics. The next two awardees from the Office of Science are Dr. Philip C. Schuster and Dr. Natalia Toro of Stanford University and SLAC National Accelerator Laboratory, who are honored for their shared contributions in high energy physics. Doctors Schuster and Toro are co-awarded for revolutionary contributions in elementary particle physics that have advanced both theory and experimental methods in the study of dark matter and physics beyond the standard model. Their accomplishments include the invention of the simplified models technique, which are now the international standard for defining how most searches for new fundamental physics at the CERN's Large Hadron Collider, or the LHC, are optimized, performed, and communicated. They are also honored for development of novel light dark matter search programs. Their work in this area includes leading collaborations with theorists and experimentals and creatively exploiting DOE facilities at Jefferson Lab and SLAC. Notably, Dr. Schuster and Toro's leadership in the Light Dark Matter Experiment, or LDMX, represents truly out-of-the-box thinking and is driving new projects in the Office of Science High Energy Physics program. These laureates are considered innovative leaders in their respective fields and together have created new methods in areas of study in microbial ecology, polymer science, and particle physics that enable us to better understand geochemical processes driving the Earth system, ion transport and self-assembly in polymer systems for energy science, and nature of the universe. Through their ability to bridge multiple fields of study and build multi-institutional collaborations, each of the laureates has strongly influenced the direction of their scientific disciplines and helped develop major experiments and approaches that are now widely used. I would like to congratulate each of the winners one more time for their selection for this award. Congratulations, everyone. Thank you. Next, we will present the award medals and certificates to each of the laureates. Mr. Howell, please come to the podium to read the citations. Mr. Rose, who will be standing in for the secretary, will join me on the center stage, and I will join Frank.
I would like to welcome to the stage Dr. Matthew C. Beard from the National Renewable Energy Laboratory. Dr. Beard is awarded in the category of Atomic, Molecular, and Chemical Sciences for groundbreaking research providing understanding and control of solar photochemical processes, interfacial phenomena, and next-generation photovoltaics, including nanoscale and organic and inorganic hybrid systems. Next, I would like to welcome to the stage Dr. Jennifer Petridge. Dr. Petridge is from the Lawrence Livermore National Laboratory and University of California, Merced, awarded in the category of Biological and Environmental Sciences for pioneering work in quantitative microbial ecology and leadership in developing and applying isotopic tools that help us discover and quantify how changing climate shapes the roles of microorganisms and plants in environmental biogeochemical cycles. Next, I would like to welcome to the stage Dr. Andrew J. Landahl of Sandia National Laboratory in the University of New Mexico. Dr. Landahl Awarded in the category of Computer Information and Knowledge Sciences for groundbreaking contributions to quantum computing, including the invention of transformational quantum error correction protocols and decoding algorithms, for scientific leadership in the development of quantum computing technology and quantum programming languages, and for professional services to the quantum information science community. Next, I would like to welcome to the stage Dr. Rachel A. Siegelman of the University of California, Santa Barbara. Awarded in the category of Condensed Matter and Material Sciences for significant fundamental material science and engineering contributions to self-assembly and structured property relationships and functional polymer systems with specific applications to photovoltaic, thermoelectric, and membrane technologies. Next, I would like to welcome to the stage Dr. Jay Zhao. Dr. Zhao is from the Pacific Northwest National Laboratory and the University of Washington. Awarded in the category of Energy Science and Innovation for significant scientific contributions in integrating material science and electrochemistry across scales to advance both the state of science and the state of technology in emerging electrochemical energy storage systems. I would like to welcome to the stage Dr. Louis Chacon of Los Alamos National Laboratory. Dr. Chacon is awarded in the category of Fusion and Plasma Sciences for seminal contributions in multi-scale algorithms for fluid, kinetic, and hybrid simulation of plasmas, enabling scientific breakthroughs in fast magnetic reconnection and self-organization in magnetic fusion systems and in reactivity degradation in inertial fusion systems. Next, I would like to welcome to the stage Dr. Philip C. Schuster of SLAC National Accelerator Laboratory in Stanford University. Dr. Schuster is awarded in the category of, Dr. Schuster is awarded in the category of high energy physics for originating new fields of study with pioneering innovative searches for dark sectors using high intensity particle beams and the invention of simplified models for new physics searches at the Large Hadron Collider. I would like to welcome to the stage Dr. Natalia Toro of SLAC National Accelerator Laboratory in Stanford University. Awarded in the category of high energy physics for originating new fields of study with pioneering innovative searches for dark sectors using high intensity particle beams and the invention of simplified models for new physics searches at the Large Hadron Collider. I would like to welcome to the stage Dr. Daniel B. Sinars from Sandia National Laboratories, awarded in the category of National Security and Nonproliferation for pioneering development of seminal X-ray diagnostics and their innovative application to Z-pinch implosions that transform the experimental capabilities of the Z-pulsed power facility and enabled novel record-breaking platforms supporting our nation's nuclear security. I would like to welcome to the stage Dr. Sophia Quaglione of the Lawrence Livermore National Laboratory. Dr. Quaglione is awarded in the category of nuclear physics for seminal contributions unifying the theory of structure and reactions of light nuclei, providing predictive capability critical for understanding inertial fusion and nuclear astrophysics, and for pioneering applications of quantum device simulations for nuclear dynamics. I'd like to congratulate the awardees again and let the audience know that the awardees will now make brief remarks limited to 2 to 3 minutes. Their longer remarks are actually available online. They're longer statements, which will be available on the award website. So I would like to invite Dr. Matthew C. Beard for his first remarks.
Well, it's a great honor and humbling privilege to accept the award. And I definitely would like to acknowledge and thank Dr. Berhe, Mr. Rose, Mr. Howe, and Dr. Harriet Kung for this great honor and award. Honor. I got notes. Anyways, I want to definitely accept this award on behalf of the great postdocs and grad students and staff who have all worked with me throughout the years and contributed to the science that I'm able to do. I want to thank and acknowledge the nominators, the letter writers who wrote great things about me, I guess, and the reviewers who supported me for this award. I definitely want to thank and acknowledge the Office of Science, program managers, and the staff. I think it's a great privilege and an honor to work for the Office of Science and with them. I want to thank my NREL colleagues and staff for supporting me throughout the years and giving me the privilege and the ability to do what I do. Definitely want to thank my parents, my brothers and my sisters for encouraging me and supporting me through the years. I want to thank my wife, Alyssa, who's here, and my son, Jackson, as well. When I was in getting my PhD, towards the end of my time there, I learned about this National Renewable Energy Lab, and I thought, wow, that is really cool. You can actually go and do good science, and you can do it in service of something that might make a difference. So I was super happy to learn about that, and I learned about it from a great scientist, Arthur Nozick. He came to the university where I was at, and he gave a talk, and I got to meet with him, and then he became my mentor at the National Renewable Energy Laboratory. And his goal was to do really good science, but to do it in after a good goal, and that is to develop renewable energy sources and so forth. So I definitely want to thank him for mentoring me, and thank you all for listening to me.
Next, I want to invite Dr. Jennifer Pettridge to the stage.
Hi, I am just so thrilled to be receiving this award, and I want to extend my really heartfelt thanks to the DOE for supporting me throughout my career, starting as a graduate fellow in my DOE Early Career Award and the many opportunities I've been given to study climate change and the effects on microbial systems. I also want to very clearly thank the teams that I work with, the technical staff, students, postdocs, and colleagues. Without them, I wouldn't be here. And I have to give a shout out also to my wonderful nominators and letter writers who inspire me so much. Thank you for your continued support. I want to particularly look to my family and thank them for all that they have done. My father was a newspaper editor and taught me to love language and well-designed graphics. My mother, a horticulture therapist, through her love of gardening, taught me to think about the connections between healthy people and healthy soils. My husband, Logan, who shares my love of tropical forest, is the one who picks up the balls that I invariably drop. And my 3 wonderful daughters who, even though they grumble, are always there to help me with the soil sampling and with picking roots. And I hope they secretly love it. I want to just take a few words to tell you about roots and why roots and the soil that surrounds them are so important to the DOE mission. This interface between roots and microbes and soil particles is just a riot of activity. Bacteria, viruses, protists, fungi, all competing and interacting and wanting that sugary substrate that plants are providing. That's the birthplace of soil carbon, which is so critical to our sustainable agriculture, the ability of our soils to support plants and prevent erosion. But in the last 100 years, we've lost an enormous amount of soil carbon, and we need to find ways to get it out of the atmosphere and back in the ground. And the work that I do and the teams that I work with, we use isotopes to trace that carbon as it's moving back down through plants, through microorganisms and into the soil, and sometimes back to the atmosphere. That work helps us be quantitative about the microbiology and genomics information we collect. That allows us to be predictive about what's coming in the future. This fundamental science is at the core of everything we do, but I've come to realize we need to move faster in translating that to applied solutions. So I'm very excited to continue to work with the Department of Energy on how to find ways to take CO2 out of our atmosphere and lock it up below ground. Thank you.
Next, I want to invite Dr. Andrew Landau to the stage.
So this is the 2-minute version of the 3-minute talk we have online. So I hope you'll all be thankful you get 1 minute quicker to the reception afterwards. I'm of course honored to receive this award for my work in quantum computing over a 20+ year career with a host of wonderful colleagues from Sandia and the University of New Mexico and around the world. And what excites me most about this award is the recognition by the Department of Energy of how essential quantum computing is and will continue to be for achieving its missions. The 21st century is going to be the quantum information century. Just look at the list of topics covered by this year's laureates: photovoltaics, inertial fusion, carbon isotopes, nuclear physics, dark matter, polymers, X-rays, electrochemistry. Quantum computers will help accelerate research in every one of these fields. To quote the musical Hamilton, look around, how lucky we are to be alive right now. Now, whether it's been leading a professional society of over 2,000 members, leading an 80-person team that built 2 quantum computers from scratch in 3 years, or just mentoring a single PhD student, I relied heavily on strong support networks at Sandia, UNM, and within my family. At Sandia, I would especially like to thank our lab director, Dr. James Peary, who gave me opportunities to brief and educate policymakers in DC. At UNM, I'd especially like to thank Professors Carl Caves and Ivan Deutsch, who brought me out to New Mexico from MIT. And in my family, I'd especially like to thank my parents, my sister, my wife, and my children for their unwavering love and support. Now, as you know, there's a generous honorarium that goes along with this award, and it's fun to think about how you're going to use it. Well, part of what I'm using mine for is a surprise thank you gift to my family that they're just hearing about right now. Honey, kids, you ready? I got us box seats tonight at the Kennedy Center to see Hamilton, our favorite musical. We've listened to it a million times, but we've never seen it in person. It won't show up in Albuquerque until 2023. And when I learned that we were going to be here in Washington, D.C., I decided I'm not going to give away my shot. So thank you again, and congratulations to all my fellow laureates.
That was fun. Now we invite Rachel Siegelman to the stage.
It's a tough act to follow. Can you all actually see me over the podium? I am so thrilled to be up here, and like everyone, I would really like to thank DOE for a very long time level of support for what I do. Just like everyone else, none of the science I do happens alone. If we're doing our jobs right, the ideas we come up with and the things we do are inspired by our collaborators, our colleagues, our students, and we end up doing things I never would have dreamed of. And so I'm just thrilled to be up here to represent that very, very large group. What my group likes to do is design polymers, plastics, long molecules that interact with each other. And it turns out that the macroscopic properties of these materials come from the assemblies of all of those individual molecules. And so what we love to do is design the molecules so we control the assembly and then control the macroscopic properties to create things like ion conductive polymers that are going to be very useful for batteries, we hope, or photovoltaics or thermoelectrics. And from the way I describe that, what you hear is that it has a lot of energy relevance, but it's a long way away. We have to do a lot of fundamental work to get there. And this is why this very long-term DOE interest and investment in me and my group and the people I work with is so important. And like Andrew, who was just up here, I was counting years a little while ago, and I realized that I've been in the DOE network subject of investment for 30 years. Some of you might be thinking, okay, EO Lawrence Award is for 20 years after PhD. The 30 years is because I was a 16-year-old intern at Sandia. And that high school experience really shaped what I do and who I became as a scientist. Also shapes how I mentor and try to bring other people into the same love for science. So a lot of thanks to DOE for a very long time. I'd also like to thank my mother and my aunt who are here. My grandmother was a chemical engineer, and I've had this privilege of having a lot of scientific role models for a very long time. Also, my husband and my 3 kids who could not be here, but I look forward to seeing everything they do. No pressure to stay in the chemical engineering field. And so with that, I'd just like to thank all of the DOE support, as well as congratulate all of my co-honorees. Thank you.
Next, I want to invite Dr. Ji Zhao to the stage.
It is an incredible honor to be recognized with the E.O. Lawrence Award bestowed by the Department of Energy. This could not have happened without the tremendous support from my family, my mentors, my colleagues, my students, and many friends. So I have been supported by Department of Energy since I was a graduate student supervised by Professor Stan Whittingham. It was with DOE and Professor Whittingham's support that I started my journey to explore energy science and technology. Professor Whittingham is also here today with us. Thank you so much, Professor, for coming and celebrating this prestigious award with all of us. In case you don't know Professor Whittingham, he won the Nobel Prize in 2019 in chemistry. So yes, Andrew, make sure your kids take photos with Professor during the reception. So on September 22nd, but back to 2008, which is precisely 14 years from today, I was fortunate to become the first postdoctor hired on the PNL's lab initiative in energy storage, led by Dr. Junu and Dr. Jad Verden. Dr. Junu cannot come here today. Dr. Jad Verden is in the audience. Jad is also our lab's Associate Lab Director for Energy and the Environment Directorate. Thank you, Jad, for coming, and thank you, and Dream, for everything. So most of my work at the PNL focuses on addressing the scientific challenges to make new battery technologies for electric vehicles. Of course, more powerful and less expensive batteries are also very critical for grid energy storage, aviation, and national security. So our energy storage team at the PNL has a tradition of integrating and validating innovations at industry relevant scales to make sure what we learn or discover is not only just scientifically interesting, but also adaptable for industry applications. I believe it's the combination of innovation and validation that has made my work impactful and also made this tremendous honor possible. right now we have a great challenge of re-establishing manufacturing and supply chain in the United States. This challenge calls for all of us to, in the battery community, to make a serious and long-term commitment, not only just to make a new and better batteries, but also make sure the technologies are implemented for industry manufacturing. I look forward to working with all those incredible people in our community to address the grand challenges together for a clean energy future. Thanks, everyone. Thank you.
Next, I would like to invite Dr. Luis Chacon to the stage.
So I have some notes written down, but I'll rather improvise, I think, although some of my colleagues are a very hard act to follow. And I won't even try. Thank you for the Department Office of Science for the support over the years, and in particular, the Office of Fusion Energy Sciences and Applied Scientific Computing Research, who have been supporting my whole career throughout the years, both on the algorithms and on the applications. Ever since I can remember, I wanted to work on fusion. That was my goal. I decided that the thing to do was to come to the US to do that from Spain, and I dragged along my beautiful wife, Isabel, who's here with me, as well as my son, from Spain to the US to study. And it has been an incredible journey for us. Los Alamos National Laboratory has been an incredible home to do the research that I have done. I always say that it takes a village to raise a scientist. It's a network. We stand on the shoulders of giants that have gone before us, and also the people that are working along with us, both peers and students, postdocs, mentees, right? That are taking the risk to work with us and push forward. I couldn't finish without acknowledging my extended family back in Spain, who made the sacrifice of seeing us leave. And my father Luis, my mother Rosario, and my siblings, Ignacio, Carmen, and Nacho, and of course my extended family beyond them. And again, thank you very much. Congratulations to my fellow laureates today. Thank you.
Now I would like to invite Dr. Philip Schuster to the stage.
All right, well, good afternoon. So I'm very honored to receive this E.O. Lawrence Award in High Energy Physics jointly with Natalia Toro. And I want to start by thanking the DOE for its continued support. And I want to give a strong voice of thanks to all of my colleagues at SLAC and elsewhere. So I prepared a few remarks, mainly focused on the science. It is a continuing adventure, and I wanted to give you a flavor for what it's about. So I work on both theory and experiment in high energy physics, and the goal really is to understand what nature is built out of and what the rules are that govern everything. And perhaps no tool has enabled progress in this field more than particle accelerators, which allow physicists and actually a range of scientists to study phenomena at really short distances, which is an arena where the underlying and unifying laws of nature become most apparent. So Lawrence himself played a pivotal role in the development of particle accelerators. It's part of the reason I'm so honored to be associated with this award. And in the wake of Lawrence's legacy, physicists have been able to reveal a deep and intricate structure of the building blocks of matter that suggest even additional principles that have yet to be discovered that we have a chance of figuring out. So today, these efforts continue at a range of DOE facilities and DOE-supported experiments around the world, such as at the Large Hadron Collider, which is the world's highest energy accelerator. And part of the research recognized by this award is for the development, essentially, of theoretical tools to help look for new physics at that facility. So a related but distinct aspect of the science is focused on theory and experiment to look for dark matter and any new forces related to dark matter. So what is dark matter? So dark matter refers to the matter that dominates our universe. So we infer its existence from decades of astronomical measurements, but we have yet to actually identify it in any constituent form in laboratory experiments, okay? Its existence offers us pretty compelling reason to think that all of the building blocks and laws we've seen are just a piece of a much larger puzzle. So given how known matter works, a natural possibility, one that keeps me awake at night, is that dark matter is made up of particles not too dissimilar from our own. So with a mass, say roughly the same as electrons or protons, the things that comprise atoms, but with their own entirely new forces. And part of the work recognized by this award is focused on the design and deployment of experiments to test these ideas. And the reason this ties into the DOE in such a close way is that the DOE Office of Science operates a range of accelerator facilities, say for basic energy sciences, nuclear physics, and high energy physics, all of which that actually have a pretty unique and important role to play in exploring this possibility in dark matter more broadly. Okay, so that should just give you a flavor for the science. I want to make sure that I call out a strong voice of thanks, in particular to my family. So in particular, my mom, my dad, and my brother, who've always supported and encouraged me, my friends and teachers and my PhD advisor for their support, and a special thanks to my many collaborators and colleagues, without whom none of this would have been possible. So I owe a lot to one particularly close collaborator of nearly 20 years, my wife, Natalia. And finally, a heartfelt thanks, she's not here in person, but a heartfelt thanks to my best little friend, our daughter, Maddie. Thank you.
Next, I would like to invite Dr. Natalia Toro to come to stage.
Thank you. So I'm very honored to be recognized today by a Lawrence Award in High Energy Physics, and also absolutely delighted to be sharing it with my very longtime collaborator and husband, Philip. High energy physics can often seem very remote from everyday life. In a lot of ways it is, but the puzzles that drive our field are absolutely foundational to the world we live in. And one of the key challenges of fundamental science today is also a great example of that, trying to understand the properties of dark matter. Now, dark matter is the literal foundation of our universe. Galaxies formed and enabled the growth of stars on a foundation of dark matter that came before, that enabled the growth of planets and life as we know it today. We know there's 5 times more dark matter in our universe than there is of the atomic matter that we, our planet, and our sun are all made of. And yet, even though we've come to understand ordinary familiar matter in exquisite detail, we can harness it to change our lives. We really don't know what the dark matter is. We're still looking for the beginning of the story of how it works. And fortunately, the Department of Energy and the Office of Science, the Office of High Energy Physics have really stepped up to thinking broadly about where and how to look for dark matter, trying to answer these questions by exploring several different possibilities in parallel and using innovative techniques and new technologies. Now is a really exciting moment in this science where several different powerful new approaches to looking for dark matter, testing different ideas for what it could be, are all coming into their own. And they leverage many of the Department of Energy's investments in areas such as modern accelerators, cutting-edge detector technology, and quantum sensing. So my own work in this area follows Lawrence's legacy of using accelerators to learn more about what our universe is made of. Both the highest energy colliders, like the Large Hadron Collider, and exquisitely sensitive lower energy experiments offer windows to aspects of our universe that nobody's been able to study before. One of the things I'm really excited about is the possibility that by leveraging SLAC's 2nd generation Linac Coherent Light Source Accelerator from Basic Energy Sciences and detector technologies developed for the Large Hadron Collider and a wealth of smaller experiments, in the high energy physics portfolio, we can look for dark matter particles similar in mass to electrons and protons, but so weakly coupled that we would never have seen them before. And do that with enough sensitivity to test compelling explanations for dark matter's origins. So realizing this and other experiments will bring us much closer, not just to understanding what most of our universe is made of, but to asking whatever new questions and eventually answering them will come into focus once we start to understand the nature of dark matter. So I want to close with sincere thanks to the Department of Energy and to the many collaborators who have explored these various avenues with me and Philip, and in particular, the LDMX collaboration that we've worked very closely with on these experiments over the last few years. My PhD advisor, who sparked my interest in using both collider data and dark matter as windows on big questions about nature, my incredibly supportive parents, and my daughter, Maddie, who simultaneously keeps me grounded every day and kindles my sense of wonder. Thank you.
Next, I would like to invite Dr. Daniel B. Sinars to the stage.
One of the joys of being a scientist is that you always get to learn. And one of the first things I learned when I got this award is that while I can create a PowerPoint deck from scratch that will be timed perfectly, I had no idea how to write a 2-minute speech. And my first attempt to record the 3-minute video that you can all watch online was over 10 minutes and terrible. So it's a privilege to receive this award. E.O. Lawrence was known as the father of big science. And as was alluded to earlier, I work on the Z machine, and that is one of the epitomes of big science in the complex. We use a very large machine, bigger than the size of this room, to compress electrical energy and use it to compress matter to extreme conditions. And so scientists have used the facility over the years to study what the conditions on white dwarf planets might be, or white dwarf stars, or the surface of white dwarf stars, or the center of planets, or the center of the sun. And of course, in the NNSA context, the conditions found inside or produced by nuclear weapons. And so it's been a privilege to work with people on that full range of science and to support the nation while doing that. Imitation is the sincerest form of flattery. And I think one of the interesting things about the DOE complex is the 17 DOE national laboratories and the academic institutions associated with them, the tools that they support, and most importantly, the people that work on those tools and do the science are truly the national treasure of this country. There's so much incredible science that comes to support what we do as a nation. And other countries are trying to copy what we have, and yet they have not yet been successful. So they look to how we structure our laboratories, the tools that we have, and even the science that we do, and they copy it. And so one of the interesting things for me is I read my own publications and who's citing my work, and it's international, right? And there's many people who are looking to build the same facilities that I use every day within the DOE. So we're truly a privilege to be supported by the DOE to do this work. And we can't take it for granted. It really is a privilege and an honor. I've worked with hundreds of people in my DOE career that played an essential role in the success that I have that brought me here. I can't possibly thank them all in a couple of minutes. But I do want to acknowledge my parents who never let me settle for second best. You know, my wife always teases me, you got to throw a game every now and then to the kids, let them get a sense of, my mom never did that. I'd like to thank my wife, who not only raised her 2 wonderful children, but also the biggest kid in the household, and make sure that members to tie his shoes and get to work on time. And I would like to thank all the supervisors and leaders that I've worked with over my career for giving me the opportunity to be successful and to create the environment where I could do the great science that I've managed to do in my career, as well as my coworkers for making sure I didn't electrocute myself or do something silly. So I'll leave it at that. But again, thank you so much for the opportunity.
Last but definitely not least, I would like to invite Dr. Sophia Quaglione to the stage.
I'm incredibly honored to receive this this year's Lawrence Award in Nuclear Physics. And I would like to congratulate all 2021 laureates. I would like to extend my sincere thanks to the Secretary and to the Office of Nuclear Physics and to the National Nuclear Security Agency for supporting my research for the past 16 years. And I would also like to thank all the students, postdocs, and colleagues that share in this achievement. Lastly, I would like to acknowledge my parents, my brother, my husband Jerome, and sons Leon and Filippo. Thank you for being here. And without your unconditional support and the sacrifices, I could have never achieved this illustrious milestone. So I think I was in middle school when I first learned about nuclei, the core of the atoms that form the matter all around us and the fuel of stars. And that was it. I was hooked and I needed to know more. And that brought me to Lawrence Livermore National Laboratory as a postdoc. Livermore was at the forefront of describing how stable nuclei are put together from their proton and neutron constituents. However, with the DOE facility for rare isotope beams in the plants and with the National Ignition Facility under construction, there was an urgency to figure out how to go even farther and describe how clusters of protons and neutrons interact with each other at the limit of nuclear stabilities and in the interior of stars. By unifying the theory of structure and reactions of light nuclei and combining it with cutting-edge high-performance computing, my collaborators and I have been able to describe quantitatively and predictably difficult to measure thermonuclear reactions during the Big Bang in the interior of our sun and in terrestrial fusion experiments. Our calculations also enabled to arrive at a more fundamental understanding of a light exotic nuclei. This took an astonishing amount of computer power and resources, and I've been very fortunate to work at a time of extraordinary advances in supercomputers, driven in large part by DOE investments. Even more exciting is now the emergence of prototypes of quantum computers that offer tantalizing prospect of exact predictions of physical properties that span the entire nuclear chart and govern the evolution of the universe. I have the privilege of joining a multidisciplinary team in laying the groundwork for the application of quantum computing to the simulation of nuclear dynamics. But this is only the beginning. Now that the FRIB experimental program has started, there is much more work ahead to realize the goal of the low-energy nuclear physics community to develop predictive understanding of atomic nuclei and their interaction. And as always, I stand ready for the challenge. Thank you.
With that, I want to say congratulations again to all the awardees and thank every one of you for being here today and those of you online and joining us in marking this important event and celebrating all the laureates. I want to invite you all, those of you who are here in person, obviously, to join us for a reception upstairs in the DOE cafeteria. But as we do that, I'm going to ask the 2021 laureates to remain in the room so that they could take a few group photos. And if there are all the 2020 awardees that are here too, please, if you could stay and take some pictures, that would be wonderful. And then we'll join everybody upstairs for the reception. Congratulations again. Thank you, everyone. I hope you can all join me in saying congratulations again one more time. Woo-hoo!